Welcome to the Coffee Compiler Club. Um, I have the flu. I am just miserable. This is day 5, so it'll probably be short today. Um, one new member, Ryan. I'm going to surprise you and say, "Hey, give me a 10-second intro of who you are and why you're here."
Sure. My name is Ryan Berger. I'm a compiler engineer at NVIDIA. I work with John Reger in college on some Alive research. He kind of got me into compilers, and I just love compilers quite a lot. And I saw that there's a coffee compiler club, so that sounds pretty good to me. So
Sounds great.
Welcome.
Yeah, welcome. Um, I have a little bit of a demo of instruction selection in Simple. And then it's just usually open forum, Ryan. It's whatever people want to talk about. And I'm just so wiped out. I'm gonna go on autopilot for a minute and then we'll switch to people ask what they want to ask and we'll just conversation goes where it goes. And then yeah, okay. Um, what are we doing here? What's a good one? So let's start with something really small and we'll go a little bigger. So Simple is my compiler tutorial project, front end to back end. Um, it's no language anyone ever seen before because we didn't want to deal. The syntax is very simple. It can be parsed with recursive descent. It is parsed, recursive descent parser, straight to SSA form, optimized in SSA. Code emission is going to be in SSA. Um, Here is a register, not register. Here is a machine instruction selected for x86, not register allocated. So up on the left, I have the address where the encoding goes. I have no encoding because I have no registers. The incoming argument is an int. Think of it as string array from main, but it's just an int. It comes in N9, infinite number of virtual registers called in something. Add one, multiply, return. That's all this code does. Like the code here, this code is pretty simple. So that one is, we'll do some other stuff for Ryan if he cares. A second here. Let's grab this one. So yeah, here's the version with machine instructions. That's going to be a jump equals. It's an Intel compare shift left by. But also, there's a bunch of ideal nodes mixed in, true and false. This is the view you get of what the actual IR looks like. Where on the left, it's the node being defined. On the right is an input. And here are the outputs of whoever gets, and sometimes they have a type if it's not obvious. Um, Fine. But then there's this view, which is not the wrong one because I got to redo it here. Of course, it all messes up with zoom, blocking the thing. This is all visible right on the left. I have this giant thing. I can't control where this freaking window goes.
Yeah, we see that.
Yeah. So compare the arg to 1. If you look in the code over here, arg is 1. Oh, there's the view. And then jump equals, so N8 is flags. It's going to be allocated to the flags register, but it's currently in a virtual register. Then either load a 5 or a 4. These will all show up in this phi down here. Phi is helpfully labeled B, but that's just like a best guess from the SSA heuristic to what to name it, but it has no semantic meaning. But B is the merge of 4 and 5. And then this is a shift of arg by 1. And then AB is the, or whatever B is, it's B is the merge of arg or twice arg. And AB is the merge of 4 and 5. And then there's a bunch of adds. And if you look over here and do like some silly math, 1 and 2 and B plus A and B plus 1, well, B plus A picks up arg twice. So it's 2 arg here and there's 1 arg there, and then you add them again, and that's how it works. So it's a reasonable job of doing code layout. Um, or basically stupid test cases. Let's look at this one. This is it would have been maybe 2 weeks, of which 1 week was spent with me with the flu doing basically nothing but laying in bed all day. So here we are, rolling sum on sum plus equals I. So zero sum register, jump, it's a non-jump. When we get done with, when Rich allocator decides there's nothing going on any edges here, he'll kill the empty jump. But then you have I, which is a phi of the fallen 0 and 13, which is down here is a 1 and 11. So it's I equals I plus 1. Sum is, sum equals sum plus I. Compare I to arg. If you're less than, you're going to go off here to 3, I guess, and return sum. So it's a fairly straightforward go do something for I equals 1 to whatever. And then we got in some Leah ops here. Let's see here. Is this a good one? Probably as good as anything I can show. And I don't have loads and stores. That's the wrong one. Let me go get this one. And yeah, so needs a 3 because div doesn't have a div I on Intel, but divide arg by 3. Then add it and 4 times arg and a 0, and return it. So that's that instruction selection. So this is mostly doing instruction selection. Yeah, that was the last 2 weeks worth of work, 1 week worth of work. I can't do my sieve here of parentheses until I get loads and stores. So this one's turned off, waiting loads and stores. Anything else somebody want to look at? The people who were working on this or helping work or trying, like Tony here is not here. He was terribly excited. Yasser's not here. He was certainly interested because he's doing the same thing, but in a different way. And so he wants to see what I'm doing. Otherwise, I'll just be done.
I have a question. I don't know if it's necessarily related to instruction selection, but I'm interested in how you're constructing your SSA.
How I'm constructing SSA?
Yeah, because I know there's a few different ways of doing it. But I'd just be interested in like kind of if there's
Right.
kind of a nicer, easier way that you're looking
I,
at
I,
based on
I have
the
a,
restrictions of the language.
right. I give a talk called Easy SSA, which
Okay.
is a really stupid, easy way to build SSA,
Okay.
and I use it.
Okay, cool. Sweet. I'll look that up then. Thank you.
Okay. Yeah, I mean, I can go do a little bit doing a live. Where is, I don't even remember where I started loops. It's probably the last interesting thing. What's in chapter 17? Trinaries? It's not a bad answer. Oh, here. Let me see. This guy runs to completion. Let's go to the parse and let's start breaking it down. Okay, so I'll just step you through parse really quickly if I can figure it out. Okay, so there's some setup at the beginning of the universe, setting up for memory. He declares he's going to parse main as a first thing. There is no main, so he's just going to declare the top level code main. So parse the function bodies is going to be very boring. I'm going to pile through here. So one of the things going on here is that I have a high font size, so YouTube video watchers can watch, but the unparsed text is up here under the parser int sum equals \4 blah blah blah. Set yourself up. Let's see here. This is the exit path, so all returns exit to the same return. Control this, that. Where's my scope here? I'm just still running through setups for every function. Here's some args. What do we got here? Okay, so here's the real first thing. I didn't find a closed curly. I'm not at the end of the text, so I'm going to parse a statement. The statement's going to say, do I have a return, an if, a while, a this, a that, a blah, 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 blah. No. Oh, parse declaration. Okay, it looks like a declaration. I need a type, so I'll just skip over it. It says type. Oh, the parser type comes. I found the type integer. So I still made no IR nodes as part of the program. Put a bunch of skeleton IR out for the top level main call, but no interesting IR for the body yet. So now I'm going to go parse declaration with a type. He's going to say something about, I'm looking for a variable. I'm still not going to put any IR out, so this is probably a bad thing to go look at, except I'm going to parse the assign. This will do something in a minute. So I found, you look over here, I ate the equals. So int sum equals has been eaten. I know I have a true, and I know I'm true. I'm sorry. I know I have a sum. Let me go show this. There's somewhere here's a scope. So as part of easy SSA, I maintain a list of nodes that are currently known to the parser in a scope. Hand in hand, there is a list of what type they are. So there's a control says you're live or not. The parser will turn out to constant fold and optimize on the fly, and he'll know that you're dead code. He'll be parsing dead code, and he'll know it's dead when he's parsing it. The state of memory, I have a variable called arg. It's mutable. I have a second copy because I went in a scope. Arg predates main, and then it shows up in as the header of main. And then I have a pointer to the node. That's a parameter to a function call. So there's a function main is the control. There's the bulk all memories because I've done nothing with memory yet. So I have only an approximate all memories been lumped in the same big pile. And an arg. Okay, I haven't found a sum yet because I haven't finished the assignment yet. So I'm whipping along looking to see if I have some other kinds of things. No, so it's going to be time for an expression. You can have int sum, comma A, comma B, comma C, and there's a couple other things that might happen here. So let's go in and parse an expression. This is a classic recursive descent parser. Bit, comparison, shift, addition, mul, unary, pause. This is going to be minus, minus, plus, plus. These are all prefix unary ops. They all fail. Post a primary. It's looking for a number. It's going to find is number. It's going to return true, and he's going to parse me a literal. Here he's going to make a parse number. On is going to say, make me a constant node. Okay, that's a node in the graph. That's a piece of IR. This is IntelliJ's failing. I'm making a node, node in the graph. And I come back out, and now I'm going to unwind from all these layers and come back to postfix on this thing. And there's some postfix ops, and none of the above. You're out. And now there's none of these above. So I'm just going to pop out, no addition, nothing. Just got a semicolon hanging right here in the parse state. It's just going to hang, 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 hang. They're coming out, they're coming out. So I found the equals 0. Now I make some decisions about my type of int sum. Are you a final? Do I need to infer your type? Are you a function pointer? Do something funny here. Can I lift the expression? This does a bunch of things, whether you're becoming a float or narrowing or widening up. All of these things are not doing anything exciting. So scope.define. I'll step over it, go back to my parser, go back to my scope in my parser. Now I have 5 variables instead of 4. There is sum. I go to my scope inputs. It's got a constant 0 for sum. That is the current value of sum. The parser knows about it. And out we go. And now I'm still looking for my semicolon, and I found it. I ended my statement when I didn't think close curly. So I'm on to the next statement, and I'm about to do a for loop. And I don't know, I was going to step through, but there's actually a lot of shit here. Parse for, you're going to match it. He's going to say, oh, you must be a for loop. You better have an open paren. I'm going to push a scope. This is like a lexical scope blocking. And then I'm going to start looking for an init list. And it only really gets exciting when it's complicated. So I think at this point, I'm not going to be helpful. You should probably go read the easy SSA paper. But the point being, I'm really going straight to SSA. I'm going to build all the parts on the fly in the parser. They'll all be hooked to on the scope nodes. And when I have a control flow split or control flow merge, I'll take two scopes and I'll blend them together, or I'll clone them apart. So in particular, if I go to scope node and I say, where's the dupe here? Dupe happens when I need to make a clone of the scope because I'm having a branch in the control flow. And everything up to this branch exists for both arms. And then I'm going to parse one arm and mutate it, and the other arm will hang around until I'm done taking this arm, and then I'll mutate this arm. Then at some point they'll merge together, and then I'll do a merging operation here. So let me go this, and I'm doing a reverse direction. I'm doing a loop. So the loop will start by cloning the loop head and hanging onto it, and just set it aside because I don't know what the back edge is going to look like. So I need to know what the fallen path is, and there'll be a back edge, and I don't know yet. So first I'm going to clone. I'm somewhere in for loop, which says go parse looping, which says I got the loop main and loop node control. I've got a head scope, and I'm cloning it. And then I'm going to use that to go compute the body while hanging on to the head. This is all done with these IR bits. So if I look at my scope, there is a loop node for the control in the head. Loop nodes have, well, slot 0 is control for everybody. Slot 1 for control things like loops, which are basically a region, an SSA region. I'm sorry, Fronianson PDF, a PDG region. And they have a fallen, this is from the start of the program main, and the back edge, which is not defined yet because I haven't found the back edge in the parsing. So there's a missing back edge. The loop has an output. It's just the scope because I haven't done anything with parsing anything, so that it'll pick up output users of the loop, an if statement that says, hey, it's a for loop. It has an exit test. The exit test will show up right here at some future scoping place. Here I'm going to dupe again. Which one is this dupe? Oh, okay, here we go. So somewhere I had been up here. Now I'm parsing the predicate. I throw down an if, a true and a false. I had to do something about the next. And then I'm over here saying, let's go look at the exit path. If you take the exit path, this is what you got. And you hang on to it because I might have 15 exits if you do a bunch of breaks to break out of the loop. And they're all going to pile into the same exit path. There'll be a big region that just folds together all the exits. So if I look at my scope, is input 0, which is control, says it's false now. That points to an if, which points to the loop. Okay. Also, the if has another input, which is a less than a bool node LT right there to a fucking Z fee. What's a Z fee? A Z fee is a fee that's missing a back edge yet. It's a half completed fee. It's a lazy constructed half completed fee because I haven't found the back edge yet. Back edge shows up, I might close that fee and it might be completely useless and get thrown away. And back edge shows up, it might be exciting and different, and then I have a real fee in there. So
By
lazy,
package, you mean end of the loop?
I'm sorry?
By package, you mean end of the loop?
The part that comes from the end back around into the loop header. Yeah.
Mm.
Like I mean, I can pull up Easy SSA, which shows this in like a clear graphic format. I could try to get the graph pretty printer to work right on the fly now. I didn't set that up right. It probably wouldn't
So
work.
it's the part where the loop start looping.
Yeah.
It starts from the start. Okay, cool.
Yeah. I mean, it's a for loop, or a while loop. It says at the top, there's a loop header,
Mhm.
and right underneath it, there's an if, fail, get out, you fall, you do shit, then
Yeah.
you come back around. That's your back edge.
Yeah, by the end of the scope and start again and test and
Yeah. So
okay.
here, so one of the things that goes on here is that this is me looking for setting myself up to handle continues and breaks and things. And then parse statement is basically parsing a loop body. So I'm going to run to here, and I better close all this shit on the left so I don't know what the hell it's opening up to. And then I'm going to step across it, and expert is the last thing in the loop, which, if you exit now, this will be the value of the loop per se. Like everything's an expression and simple,
Mm-hmm.
although the syntax makes you think about statements, but the implementation is all just expressions.
I
So
think
this is,
that's right. That's the right way, at least
yeah,
to me.
fine. So the add node here is the sum of two fees. It's sum is equal to sum plus I. Well, one of the sums is a fee for a sum, and one of them is a fee for I, both of which are still kind of lazy at the moment. So this one has a label. This is like a hint. It has no semantic meaning. The compiler ignores it. It's just being carried along so you can debug a little easier. But it says that's one is sum, and this one is labeled I. So it's sum plus I. But both of these are lazy fees, which might disappear. They're not going to in this case. And in many other examples I have, the point of being a lazy fee is that if you get built immediately with, you're untouched. The variable in question, the parser has no idea if the body loop will touch a variable or modify it or anything. So he has to put in lazy fees for everybody. Then when he gets to the bottom and closes the loop, he discovers that he didn't touch some set of variables. So all of those the lazy fees get deleted immediately without living into the IR any past the edge of the loop.
Mm.
Yeah. So somewhere down here, I'm going to now do the partial sign for the next part, which is I++. I'm probably not going to get it. I might be able to get it. I step in,
You
I
can
step
easily
out.
detect if you are not incrementing the counter inside the loop here.
It's the funny way the for loops are laid out.
Mm.
Here's the layout issue. It's effectively, this is the syntax sugar.
Mm.
Some variables are equal to some inits, semicolon, while test, body next. But you write it as var x is init test the next clause or increment or whatever.
Mhm.
Well, if you parse the thing this way, you have to parse body before you evaluate increment.
Mhm.
And
Mm.
so instead of me trying to parse the increment off to the side and hang on to it, parse the body and then stitch it in after the body, I just put the text wad off to the side. I just find the endpoints and like save them off to the side, save the endpoints off to the side. Then I parse the body, which builds the whole IR for the body. Then I go back and I reparse this text. That's what happened down in here. Down in here. I'm now about to, so, I set the position for the parser to wherever the next was, and then I'm going to run to the next end, and then I'll unwind back past the body. So parse point has moved. He skips rapidly over the next part without actually doing anything, finds there's a close paren. Oops, let me add Aaron here. Then he goes, parses the body way over here. Then he saves this point, pops over, parses the next, pops back, and carries on.
Mm.
And then one of the reasons I just did this is I looked at the return from parse assign, and it's going to be I because the next was I++, so it's going to give me some version of I. Whatever, fine. So I'm done with that. And then you fall down to the end, and the end loop will go and do merge, except I missed it. Darn it. I didn't have my breakpoint set. He could have, should have stopped at end loop and said, I'm merging the back edges and the head edges, and that will put fees in. So let me instead show you. Oh, here's Bill Verner's too. I'll run this down again or not, according to whether or not. Oh, it paused for, let me try again. It paused for people joining. Kill all the bonus breakpoints. Okay. Well, okay, so then you get this kind of IR dump. It's actually not very pretty till I do code motion on it. There's a start. There's an immediate one. There's a bunch of high order constants that represent the default values as input to main. Um, Fine, there's an immediate integer 0. Here's main as a function header. He has parameters. They're helpfully named arg, mem, RPC, but they're of type parm node. Functions are of type region. Function nodes extend region, and therefore parm nodes extend fees. And they have default inputs, which are what happens the worst possible scenario of what you can call main width legally. Fine. Then there's a loop whose fallen path is 8, which is back to fun node 8, whose package is 29, which is this if true. So if this is test is true, you're looping. You have a fee that's out of order printed because I haven't done scheduling yet. So here's a fee for I, and here's a fee for sum. And fee for I starts with initial value of 4, which is the initial 0. Fee for sum has a fallen value of constant 0. The back edge on I says go to 40. What's 40? Well, 40 is an add of 25, which is the phi I and the number 1. So I equals I plus 1 in a tight loop. Sum is the same thing, except it's an add of sum itself. 37 matches to 37 on sum, and 25, which is I. And that's it. So that was SSA form built without any of the classic SSA algorithms. You just parse it straight down and build it immediately on the fly. This has been in the C2 compiler and hotspot for 25 years. It's way the hell cheaper and way the hell faster than anything else I've ever seen. So, that's me doing a little bragging, but yeah, it works. And so, Ryan, did that like overkill?
No, yeah, this is great. It is very interesting that you're kind of constructing everything at once. I don't know if I've ever seen that, but I also really like it. So I think I'm going to take a look through this code
Excellent.
a little more.
So there's also the simple project, which is this as a GitHub tutorial. You just grab the code and do something. We have people who've been building versions in C, C++, maybe C++,
Okay.
Scala, Rust, Go. I think the Go port has stalled. The Rust port, I think the guy's waiting for me to complete code gen before he comes back alive. I don't know that he would care if you would to pile in or start another one. It would be all fine. So but that's a convenient way to go learn how to go do these things or how it works.
Is everyone kind of doing their own thing there? Like some people are doing instruction selection different, or is it just straight ports?
I don't care. So
I would say from my experience, I port the core verbatim because there are too many things that are going on, and that's a great way to start the feel what exactly the code is doing,
yeah.
and then maybe a second port which will take advantage in the language you're writing into the most that it can.
I think most people are following along pretty closely and fighting already the language mismatch. And that's enough of a fight. And they don't want to fight another thing.
Yeah. So I have a couple of questions actually. First, we parse and we optimize, but we are always assuming that anything starts from main. What about libraries? How to optimize those? Because they're obviously they don't start from main. Aren't used. How to optimize them?
Yeah, same. It won't make any difference. But hang on, let me see if I can throw in a nicer example here. Let's see here. It's whatever functions show up, which I'm always not remembering because there's just too many things going around here. Yeah, here you go. Oh, I think I have a really crazy one in chapter 19, actually. Yeah, okay, so I started down a path of doing a string implementation, chapter 19, but I'm missing a bunch of key things, so there's no string implementation. And I want to do some things before I try to go declare a string implementation. So instead, what I'm going to do here is say, okay, so here I have a string. Okay, it's just a struct. It has no other thing. It has an array, has a hash code. There's an equals call. Now, at some future date, this equal calls will become a member function of string, and I can't handle it right now. So it's not. I got it outside. So your self pointer should be a member pointer. If it's inside, then everywhere I say self dot, I wouldn't need to.
Hmm.
So this is one of the, here I can fake it, but I don't have a real string. But you're asking, library. Well, I have a bunch of functions here. They're
Mhm.
all going to be optimized. And then they can cross optimize, they can inline, they can do whatever. They're all being optimized all at once right now. If this were library code, it would just be a pile of, library code, same. And when you're done, how do you go from a library is you'd have to export something and you have some decisions to make on what you're going to export. And then when you import, you decide. So if you export and import to IR, you get whole program compilation out of your library. And if you export and import, just binaries, you get the classic thing. We're going to link it, be done.
Hmm.
So that's sort of the thing here. So let's look at this guy. Okay, so somewhere in the world, oh, I didn't do code gen. Okay, I didn't. So I have bad printing. So here is, why am I doing it this way? Let's do it the other way. Let's try this one. This might be a little easier. There's a start. Here's a loop. What method? Oh, I don't get the headers for the function bodies. Oh, that's why I wanted the other one. Oh, all right, fine, I'll go the other way. Yes. So self as an argument, S as an argument. These are function headers for equals. Load the CS field. I don't know why that's twice. That's very weird because the address is different.
So here, let me see. The question is right now, let's say we're looking the hash code function, but the code function isn't used anywhere. Wouldn't be just declare dead and that code eliminated? How would you
Right.
emit code for that?
Right. You basically, oh, that's a good point. I am, well, equals is being unused, but hash code's not. That's interesting.
Mhm.
So the thing there is you simply add an extra caller called, well, for me, it's been called the root. It's a start node. It's everything that every other program that ever links against you will ever send you or read or write from you.
That would
Rest,
declare it
And how do you
alive.
express that exported list?
yeah, right. So if you're attached to start and you're attached with a call, call with a, oh, he's not going to show it here. I have to do this other version.
And Aaron is asking how do you express that in source, maybe.
Right. So I am looking for this layout is not the one we're looking for because it doesn't understand things well. So equals points at number one to start. It's a function node. It's the function header. He has some parameters, including RPC, mem, self, s. They all have default arguments. Those default arguments will be the worst possible legally allowed types you can pass into equals. Somewhere in the universe, there'll be a stop pointing out a return. The stop will prevent the function from going dead. If I were to add, and Simple doesn't have this right now, if I were to add a notion of a local function versus an exported function, all the local functions would go dead just as you suspected and would die. And you probably wrote them for a reason, so they probably wouldn't all die, but you would inline them and maybe they would die or not or whatever.
But in order to export the library top level functions, if you will, all of the things has to be reachable in order to not go dead. So in order to be optimized as such,
Yeah, so everyone who didn't go dead gets optimized as they go. And in fact, the go dead is part of the normal optimization. There's nothing
yeah.
special about go dead.
But we have to stop them in the library case because you have to use the function when you import them.
And I'm just now getting to that. So here's the return. He has one user, the number two. That's the stop node. that prevents him from going dead. So by default, right now in Simple, everything is being treated as being exported. Every
Okay.
function is being treated as being exported because it's hooked by stop.
And it will emit code for all the functions. So
And well, yeah. The code walker just walks from stop
yeah,
for
so
everything.
it will emit code for everything
Yeah,
live. So we can assume that it will emit code for all the functions
yeah,
and as library product, if you will.
yeah.
Mm.
And like I said, this is sort of overly strong. You surely want internal functions, so you'll want to have a private public split.
Yeah, so maybe we have to some export keyword in the source in order to optimize maybe the call graph and the chains and treat it as such in order to get the best version of that function of that call graph.
Right.
Hmm. Okay, cool.
Yeah.
I
Okay.
think I got it. Okay,
Sorry.
I think I got it. So
Okay. So it's all done crucially with the standard liveness that everything happens with. Like there's really nothing special here at all. It's all dependency edges. You either have the edge keeping you alive or you don't. And if you don't, you die. And if you're
yeah,
like
but
a private function and you get written and you're not hooked by stop during the run of the parser, he'll keep you alive. After the parser's running and there's no more chances of anyone picking up an extra reference to this thing, you let the optimizer crank around. The optimizer will come along and say, dead, throw it away. Or
mm,
not. Or he might
mhm.
not be dead yet, but he might decide, optimizer might decide, let's inline it, one less use. Let's inline, one less use. Let's inline, last
Okay.
use gone, now it's dead.
So when to stop inlining. So
Oh, that's inlining
that's
heuristics.
yeah,
That's
yeah,
a
yeah.
that's a rat hole that has no bounds, or rabbit hole
Yes,
has
uh,
no end.
yeah. Mm. Because yes, I think I got it. So all of the functions has to be reachable at the end. They're not calling each other. They are kind of separate flows because they may be not calling each other, but they has to become library code. So has to become callable. So they has to become something that can be linked or maybe imported if it's source, or maybe intermediate optimized format that is already optimized by the CF node. So mm,
So here is, and this one might do better. I might go do this one. The other view, let me see if the other dump works well on this one. So here is this function like down here on the right in the graph. It's just square is x times x, and then I square argument, I square 3. So here is the function for square, has an argument, multiplies, returns. The 20 here says that I'm hooked on the basic block for node 20, which is going to be the function header for square, which this print's not showing, but that's all this guy's doing. So multiply x by himself, himself, and return. Okay, here is the function pointer for square, a call which takes the function pointer for square, and it's in the block for main, and it's taking the memory from main, and it's taking arg, and a call end or call exit, or even call epilogue, and it returns a result, which is the result of calling square.
you say main, but for libraries there isn't main.
No, but that's because of this example. What I'm trying to show here is I have calls. The calls can be
Mm.
linked internally.
Calls can be treated as a separate products, if you will, separate things. Maybe no, I
I'm
don't
sorry.
know
Yeah,
how
I
to.
understand that. I'm just saying the libraries will be kept alive
Mm.
because you've decided you're going to export. Therefore, stop will have a hook on them, and therefore they won't be dead, and they'll
Mm.
you'll do something with it. Now, at this point, at some point, you have that code. What are you going to do with it?
Yeah.
Well, you dump it in some library format, throw it out, put it
Yeah.
in an object file.
Then is the question of the what's the format for the final product. Maybe you can reserialize it back in the source form. Maybe you can emit it in
Yeah,
something
right. There's a lot of
that
ways
is
to go here.
optimized. Maybe you can emit it as a library to be linked with it. That's a separate.
And I come from a long history of jitting code. And these things
Yeah,
happen all the
that's that.
time.
Yeah, smoothly transition to my next question. So this is live CF nodes when it's generating code, but how we use it in a JIT fashion. So you have to emit something that will help later the JIT. So
Well,
how do
this
you
is this is the jet.
Yes, but it's not running code. You don't have profile data. How would you aid it in a running program to be jitted
Okay.
further?
So
Okay.
if you were intending on actually running a legit jet,
Mm,
you almost surely want to have profile data, which now you need a complex managed runtime.
mm,
As soon as you have a managed runtime, it's pretty easy to flow into garbage collection as well. And then you get the whole scenarios for whatever Java and JavaScript look like.
mm,
But you don't have to do garbage collection, or you could do, Python ref counting with the lazy background, I'll catch cycles later thing. A lot of ways you could go.
mm,
Um, but if you're jitting, typically you want two or three tiers of execution strategy. One that executes without compiling, so an interpreter,
mm,
collect profiles to say what's worth compiling, and then one that compiles now with profiles. But you don't have to. You could totally start out by saying, I'm going to take classic C style performance number heuristics. I totally count loop nesting depth right now.
mm,
And I could also add in at every test, the frequency splits in half, unless I think the test is lopsided 90-10. Java has a bajillion safety checks, so they're lopsided 1 in 1 billion versus, the rest, versus, near one on the other side. Um, you can fake your way to those kind of tests and get a decent frequency choice, which you still, if your only execution strategy is to JIT, then you have to JIT everything. On the other hand, you can do an okay job with
mm.
what the code should look like, same as any ahead of time C compiler does.
Yeah. So we're in the realm, let's say, profile guided optimization. So you have some data though that you can work with it in order to improve the optimization.
Yeah.
So
If I have profile data, there's a lot of things that happen.
mm,
Of course, C2's been doing that for, decades. So the
mm,
obvious things are you decide what to compile at all, you
mm,
decide what to inline, you
mm.
decide what's hot and cold for doing basic block layout, what branches will likely be highly predictables, never fail, all the safety checks never fail. So you can do all the layout, make that all be cheap and easy. You get the register allocator knows where he wants to put his spill code because of frequencies and so on and so forth. There's a bunch of things that come out of if you have it.
Okay, but of
Much
course, it has the source. It has to be emitted to something that amendable to optimizations later. If it's a binary, then it's a final product.
right.
And
If you want to pull in a library, so in the case of Java, I pull in bytecodes as a library. Well,
yes,
you can't execute bytecodes except via the interpreter, or you
mhm.
JIT them, and then of course they get JITted and inlined and highly optimized accordingly.
And so we first construct the CF nodes, but we are here straight in the CF nodes, straight from source. So there is not intermediate product like a bytecode, like something that you can hold off.
So
So
as far as I'm concerned, any standard normal parser can emit C of nodes, SSA form IR directly every time, unless your particular language needs an AST at some intermediate step for other reasons.
So interpreted mode would be here straight from source, emitting the CF node, and then interpreting straight from
A
the
lot of different ways you split that one. Yeah, you could. I have I have a
that.
C of nodes evaluator. Here, it's this thing
Yeah.
right here.
Okay.
Eval passing in a two. Oh, it didn't. What happened here? Yeah, it didn't break. So what happened? It evaluated two, which is uh, uh, two squared four and three squared nine comes to 13, and he checks it's 13. So there's an evaluator on C of nodes. You could. I don't
Yes.
claim it's a super efficient way
That would be
to.
your yeah. That would be the interpreter mode in Java
Yeah.
instead
If
from bytecode. Yes.
if the goal was to always go to always parse once into something like C of nodes and then have tiered compilation, you would interpret C of nodes directly. Like, I'm just proving that you can. I'm not
Mm.
claiming it's the best way to do it. It's not a terrible answer. Once I'm done with local schedule, it's sort of basically in the form that you could do like a bytecode evaluator. It's roughly the same difficulty as a bytecode evaluator. Now, the one I have is stupidly quick and easy to write and not very efficient. But standard kind of go around you did for hotspot for the bytecode interpreter would apply, and you could have a reasonably fast
Yeah, and an
web
interesting part
interpreter.
would be serializing the CF nodes graph in something that you can ingest later.
Right. And the CF nodes graph is directly being evaluated by my evaluator right now.
Yes.
Okay. So it's not serialized, it's already serialized in that
Yeah,
sense. It's just
it's
a
it interpreted. It's parse the source to graph to CF nodes IR and interprets it directly.
yeah.
So it doesn't
Wonder.
emit internet. It doesn't emit anything intermediate. So it directly evaluates the graph.
Oh, you know what? Why don't I try let me try. Oh, I don't want to do that yet. Do it here. Which is gonna die because I haven't set it up here. Why? Let's go to the viewer because it both shows the. Let's see if this will work. I'll have to. No, maybe I won't. Okay. Let me go back to. Mark died and re-entered. Okay. Let me go back to. Get the source code. Yes, this code. Stop this share. Start this other share. Hello. This one. Yeah. This one. Okay. Look outside, 50 frames. This is a fun toy, but you see how busy the graph gets while I'm building a loop. Here, hang on. Or building a function as well. I was just going to run to the end. I wasn't going to stop in the middle. It cleans up a bunch at the last second. Whoops, and then it changes where the damn clicky buttons go, and you click outside, and you thinks you're trying to scale shit. Okay, and then this should be here, and I should be able to zoom in. Okay, so somewhere in the universe, I have a return of an int. So the red stop says keep this function alive, and he says I'm the square function, and I want to multiply my x and return it. That's the IR for the square, but it's kept alive by stop. Here is the main, which points to return, which has add a call of a call and a call and a call. And I need to update call in displays. That's interesting. And then the call here says, I take as an argument the address, which is the square function, and a 3. And this call says I take as an address the square function, and I take, you can't really see it, the light blue line here, arg. Let me see, scope in a little bit here. And then everything else is like boilerplate because there's no memory things going on. So they're bright and they're bold, but nothing happens. And in both cases, for arg and int, the default value is any random integer can be passed in general. But this is the optimized version. There's hardly any optimization to be done. Optimized version of this little program. And the steps that the parser goes through are broken out here for Ryan's sake. This is how the parser, blow by blow, this guy takes snapshots from the parser and puts them in dot format, which D3 and dot kind of make an okay job with it. It gets crazy when you get bigger.
Yeah.
But the point being is that this edge exists, so this function is not dead. So that, Theodore, you okay with what's going on here?
Mm-hmm.
Kind of, sort of,
Sort of. Yeah, maybe.
maybe. Okay.
Maybe.
Yeah. It's uh it's the same sea of nodes that I add nothing to force functions to stay alive. I do nothing special to force them to stay alive. It's all about you have a dependency edge or you don't. And if you don't, the standard people rules apply, and you get eaten up from the bottom, you're dead, and then you get recursively removed, and that will wipe a function out and take it away. Now, in the other view, which didn't show here, it's kind of funny that the graph displayer needs to be fixed for call-ins. That's why. I will have linked uh, the call to the square function. And what that means is that the call has built a call graph. So in this particular case, I will have built a correct call graph as well. And I've chosen not to inline because I limited my inlining to the most stupid things, I think return constants or something, just because I wasn't trying to do an inlining heuristic. I think I know. I inline if you call exactly one function and the function is called by exactly only you. And then I'll inline you. But the function will remain alive as well. Oh, it won't, because I've decided that means I can kill you because this is the whole program. Yeah, for a library, you need to have an edge saying, keep me alive.
Okay, that's my point, because all of the libraries, their internal structure, there may be private functions that they call to each other. They can optimize the way, inline the way, but at some point you have to stop into something that should be callable from the external code.
Right. So you have to have something that says keep this thing alive.
Yeah,
Here I keep main alive as I'm calling it.
yeah, but main it's one function, so all the functions in order to stay alive has to point to main, has to be used in main somehow, and in order to be emitted, all the functions
Right.
can.
There has to be an export or not export or whatever.
Yes.
So the trivial answer is I just don't delete you from stop until we sort out what the right syntax is to say this guy is going to be
Yeah.
export.
So if you say export function, that would mean that boundary, that anything up to that point is amendable to optimization, and when you hit export, then it's time to emit.
Well, what it really means is that this red edge will exist and not be removed.
Okay.
And everything else is subject to fair game in the optimizer.
Yeah. Okay.
This is, I'm saying, this and only this. It's the only thing you need is that edge, and everything else will be optimized, but it'll be kept alive because, somebody's got it.
Okay. Cool.
All right. Wow. Yeah. I'm losing my voice.
I have a link to that easy SSA paper. I was looking around and I was not able to find it.
Yeah, just a second. Throw it in Google Docs. We throw it in Google Docs about.
Is it every meeting?
Sorry? You're very quiet, by the way.
Oh, I'm very quiet. Interesting. Is this better?
A little bit.
Okay.
Put the link in the chat, or where I am.
Oh, you put the
Okay,
link in the
thank you.
chat?
No, for the paper, for the docs.
Oh, for the docs. Yeah, okay. I'm trying to find. Let me get to the paper link. Like I said, I pulled this link out. Here they are. Probably don't want to do that. Let's see here. Copy this. Now I need to copy the Dropbox link.
Is this better? I assume this is better.
Yes, this is
Okay.
better. Maybe the other one without breaking anything. Copy Dropbox link. Okay. These things we'd like to think, yeah, it goes. So these have been presented on this forum at least 3 times, like each. One of them is building SSA, and I try hard to not be sea of nodes specific. And one of these is more specifically about sea of nodes and covers other topics that the usual SSA things don't really need to cover, like how you handle memory and stuff. But easy SSA, and I don't remember which one it is. I can probably hunt up the PDF links instead. Guys, they came out for free as the wrong link. Let me go find that. Geez, I hate Windows. Thanks, Mr. Windows, for nothing. Dropbox. Presentations. Easy SSA. Hey, look at that. Oh, look, I don't have. Where did my PDF version go? Hang on. Export as directly as PDF. Yes. Thank you. Okay. Here is a PDF version of Sea of Nodes, which I'm going to replace. See if this guy's a little nicer. And here is a PDF version of Easy SSA, and I'll replace it with the first link here. Copy Dropbox link. Okay. I claim theory says those should be a little easier to deal with because they're PDFs instead of OpenOffice.
Thank you.
Yeah. Yeah. I kind of walked away from doing a lot of things in the, oh, sorry, let's do this. Doing sort of academic things directly, and I just went to giving public presentations, of which this shit I haven't done in a while. Fine.
Steve, can you maybe upload this to the GitHub repository for the Sea of Nodes, because those things are not gonna be easy to remember.
I think it's there. Let's go look. As soon as I can go figure out how to get there. Repository view on GitHub. Chapter docs. Where is the, probably one of the first few chapters we'll have in the docs section. Yeah, here you go. Simple graph-based. Now, these are the high-level published papers. I thought I had these up in here. You're correct. They should totally be here.
And maybe like in either a separate repository or a separate docs folder, like not in some chapter, then it should be easy to navigate to.
Right. I would have said they should be at this level here. This piles of chapters, but also the docs should show up at the screen I'm on as a reasonable way to go do that. They might show up in a later chapter because I have a lot of, things going on and why and where and links, this and that and blah, blah, blah. I am not seeing, you're correct. It's not in an obvious place. It should be in the repo. All right, I'll make an effort to get it in the repo. Where was the first README that had a bunch? Chapter 1 has a bunch. I claim these probably should be at the top level. And then the other two, Easy SSA and the Sea of Nodes discussion. Okay. All right. Yeah. That's a good point. Thank you. All right. I'm losing it. So somebody else has to carry the conversation, or I'm going to collapse in a puddle and suck on my flu.
One last question. In A, there are no inputs and outputs like in Simple. How do you represent them?
There are
By
inputs and outputs in AA.
Okay.
Just like
I missed
Simple.
them. Okay. I just missed them, maybe.
Well, I use shorter names.
Hmm.
A lot of things that happened early on in Simple was to be a little more Java-ish looking in an effort to be a little more friendly to whoever modern people think what things should look like. But in fact, it's a compiler and it is not any kind of reasonable or normal Java application. So the normal Java application best principles or whatever best practices are full of shit anyhow, but they're really full of shit on a compiler. Um, fine. So the names are longer on simple, and in AA they're called like use and def. It's a classic compiler term. In AA they're called like inputs and outputs.
That was one of the discussions we had years ago when we were first talking about the syntax of AA, is that one of the lowest syntax ways to decide what gets exported is to simply say the last return of the file is the thing that was exported.
Yeah.
So you just create a namespace at the very end and be like, at brace, list of functions that you actually want to expose, close brace.
Yeah.
And when somebody says import that file, what they get is simply the last thing in that file.
Right. Which is a struct containing all these functions. And
Or a function.
I'm sorry.
Like if I want an import to return a function or a value as opposed to a struct, I could do that.
Yes. Yes.
It would just be a standard practice that you return a struct, but some libraries want to have configuration. Can you please inject dependencies into me? Well, if the thing that I return is a function, then you just say import this package paren, a bunch of parameters paren, because the thing that it returned was actually a function and not a struct.
Yeah.
Fine.
Yeah.
Like it's very light syntax to just say you return whatever the last syntactic object is at the end of the file as you're reading it top down.
That's not a bad answer. I need a shorter struct declaration syntax.
So what are you saying, Aaron? The last thing that you wrote in a file becomes the export. It becomes exported. Is that
right?
Okay.
Yeah, this is like
so if I have F, G, and H that I've defined, then I simply say for the very last line, at open brace, F, comma, G, comma, H, close brace.
Yeah, but I'm going to, which actually I don't have to say return either. So I have to do a struct though. And the name doesn't matter. I'm not exporting G, so G becomes local only.
Okay.
Taken as the whole.
But that's simple. I was suggesting for AA, you do the same.
I'm exploring the syntax. It's not terrible. You could explain that this one is supposed to say export. I don't care.
Right, but I would leave that as tradition, not anything that's being enforced outside of, say, a linter.
Right.
And maybe export is just a function, and instead of struct, it calls for export, and anything inside the scope becomes export.
So this is inside some file.
Yes.
Somebody says import, which is just a file read of the above file.
ABC, okay.
But it's assigned to a struct, which I don't have a name for. I'm going to give a name here. And the definition of X, struct X, is given by what the import gave it. So somewhere in life, I say X.F of, it's just like you get in Java, name dot whatever. You can have a reason to export the erase the thing, shortcut the names. You have to say X all the time. Right.
Oh, yes.
Yeah, and here's the AA version where the struct field has been decreased to an @ sign, which I can throw into simple.
So this has become exported in the last line.
This is now exported.
Yeah, just whatever's at the end of the file.
Okay.
So if you're in a REPL, you'll execute each thing as you go and show the return to people. But if you're in an import, you just run to the bottom and then take whatever's at the bottom and return it. And if there's something that's dead because it's not in the struct that's at the bottom, then fine, it's dead. Optimize it away.
That can serve as a natural boundary to optimize inside anything and export. Just that would become callable when you import it.
Although you probably need to lose that last semicolon so that you're not returning null.
Oh, that would be tricky.
I think that changed a while ago, Aaron. I think structs demand a semicolon and it won't be the return of a null. In simple, not in AA. In simple, that would be struct as a statement. It needs a semicolon, but it's not the value. It's not an empty statement, which would be a null. It's in fact a struct. That should return a struct. But whichever way the syntax goes, be clear that you're going to get a struct return here.
But in a sense, it
Okay,
weakens
so if I actually
the
wanted to return null, I would need to add a
0 at the bottom.
Hmm.
Yeah.
Yeah, that's fine.
And
in
then
a
the
sense,
struct is not being returned, by the way.
in a sense,
Everything's dead now.
it weakens the import because with the normal import, you can import any of these functions, but if you want to import only the exported stuff here, you have to keep putting it inside.
You know, there's a thing where you could say, I want to just pick parts out.
Yeah.
So if Java, I say import Java lang math,
Yes.
and I get like math dot blah blah 50 functions, right?
Yes. Yeah.
And you say, oh, I want to filter again. Okay, so
Mhm.
I can give you syntax for filtering again, but then it's the obvious stupid one. But then you maybe want to do something a little different about it. The obvious stupid one is I want to just suck in pi. Well, I got a struct. It has a pi field. I say, well, fuck. Okay, I just imported math, math.pi out of all the
Yes.
math things. But that only gives me one. But the same kind of pattern where I say, I want to import these blah, blah, blah things and break out these blah, blah, blah. You know, you need a little more syntactic sugar here. And then we're there. And the little more syntactic sugar is like, let me give you an explodey left-hand side. So this is, yeah, you're doing it this way. I would claim you do it on the left-hand side. Let me give you an alternative syntax while you're typing that one. And that would be, I'm going to make a tuple, which is probably really this way. I'm going to say pi, foo, bar.
Well, that was your idea for AA, was tuple unpacking.
Yeah, and tuple unpacking. So I get a full struct in. He looks up the pi, foo, bar fields and pulls them out into the unpack and throws the rest away.
Yeah, that's not a bad answer either, because
Yeah. Yeah.
you can deduce what is where the pi, foo, and bar really comes from.
Yeah, because I'll do type inferencing on the right-hand side, which will come back as I have to do something about reading what the import does.
Yeah.
So he probably has to
And
actually suck the file in.
That's actually nicer because you can annotate the types here, but here would be awkward to ascribe. You have to ascribe them maybe. So yeah.
Yeah, I would have to say, float pi, not, yeah.
So how likely is it that without doing anything special, the fact that you tuple unpacked and only took 2 of the 3 fields in a struct, would you realize that the third field was dead and not even compile it in the library?
So in the imported version, which by our current description basically amounts to a full inlining of the whatever the condensed body of math.simp is, it would be known dead. So he would bring it all in, pick out the 3 that he wanted, and the rest would be known dead. Yes, they would be just by natural, no extra work done. And the evaluator for whatever the optimizer phase for doing dead things is infinitely quick, and it's just like a garbage collection cycle. All dead things don't even get visited. It costs nothing to have 1,000 dead things. They just get ignored.
And I assume you're imagining the string that is inside the import call is just the relative path from the file you're in
Yeah,
to the
now
file.
we have to write. So what is the syntax for how import works?
Because now you have this question of, is this the path from the root of the repo, or is this the path from the file to the other file?
I claim I prefer root of repo, but people will all have my module is better style than your module, and I hate yours and I hate yours. So we're all going to agree to hate each other's modules. But
I mean, I've seen my arguments for both of if you have a bunch of dot slashes, you can move things around.
Yeah, right. Well, people can, right, but I don't want to.
And if you just start from the beginning, then
Can you put
if the
an
first
URL?
character is not dot, then it wasn't a relative path. Okay, fine.
Can you put an URL in there? Like if you want to import
Right.
something directly from a GitHub repository.
Yeah, right. But he has to do the IO at runtime for this code. Yeah.
What makes it runtime and not compile time?
I guess you could argue go both ways. Sure. Yeah, I could do this here, you know.
But you have to have a way to prescribe what you want, compile time or runtime. So
The compiler would have to say, this is a known static string. Now we have two choices of semantics. One is do it now at compile time and do it later at runtime. And the other version of this is I said, I have an import of a string type thing that I evaluated horrifically. Who knows how I evaluated it? And I'm importing some unknown library. That one has to be in the runtime because I don't have a string at compile time. I can't tell what I'm importing. So those are kind of funny issues. And I claim that the runtime dynamic library load probably should be under another name because you really need to mean it. Because unless you filter the fuck out of that computation for that library name, like, cross file, cross website hacking screams at you, just like something bad is going on here. Are you sure you want to,
Yeah. I would just have two functions, import and eval import. And
Yeah.
import happens at compile time and eval import happens at runtime.
Yes, yes.
yeah.
And
So
secondly,
modify
this is more of a tooling question than a language question, but I would split it. I would say when you say tool space build, that you don't go fetch any of those URLs. It's only when someone says tool space fetch this thing that you actually touch the network. And you store all of the networky ones locally in some database, and only when someone specifically asks for a fetch before a build
So
that you
yeah,
do the
now you're
fetch.
talking, let's build.
That's a tooling question.
Yes, yes. Now yes, outside compilation strategy. What is the module build and module caching strategy? And I'm was intending Simple to be a compiler tutorial and not a full-fledged language design with a module system all baked in as well. We might go there anyhow, but that won't be the first cut.
I would say we can
Right. So my question is, how much does having you can import from an HTTP URL mean that you don't need to have, your CPAN for Simple?
I don't need to have my what?
CPAN?
CPAN?
The Perl online thing?
Oh, the Perl one.
CPAN, PyPy, NPM.
What's the one on R? That's the one I'm used to. Fine. Yeah, I know Elm has one.
Maven.
On
Yeah,
R that
basically-
was on R that was called CRAN, Comprehensive
Right.
R Archive Network. It was inspired by CPAN, I think.
Okay. I don't know.
My point is, Simple should probably not have one of those.
I shouldn't have my own. No. There could be, if we go a long, long ways and the language takes off, there'll become a request to have a curated set of libraries that are known in a good place, and they might have a funny, name that'll be like import from Maven or import from the known place, which will turn out to be Maven or whatever it's going to be. And then, some shorthand for saying, give me the system library, which everyone has to have anyhow. You want strings? You're going to write them yourself. You're going to import them. Because strings are going to be built in the language from the language, not as a primitive in the language. That's my current theory. I think I can do strings, a really good job with strings that are just simple code. But you don't want to write them yourself, so you're going to import it. Yes. What are you writing? Don't tell me. I don't want to know. Fine. So there is a path forward, the same path I'm having for AA, a path forward for imports. Bunch of features want to be added, not there yet. People want to pile
I do
in.
wonder whether it makes sense to have like AA programs just sort of always ceremonially start with some line that's like, go import the standard library.
Yes, of course. Just like every Python program, whatever. Yes. Many C programs, pound include studio. Fine. Yes.
But Python doesn't do that. You can actually get pretty far in Python without importing anything just because those functions are around.
Yeah, okay. Yeah, that's
Where there's
true.
some question of like, should you have this line at the top or should you just assume this line at the top?
That's a flag that you say, I want the bare version, don't assume anything. And it's for systemy guys who are trying to get a startup that doesn't require a giant library and they don't want to go touch the interwebs as part of their startup of things or whatever. Yeah. Yeah, you want that.
And you think that that's less annoying.
Yeah,
It's
but
less annoying to make people opt out of the standard library than it is
you have
annoying
to
to
opt
make
out.
people opt in on the
Yes.
top of every main.
Yes. You want to opt out as available, and you want the default is to opt in. Yep.
What made you jump to command line flag rather than a piece of syntax at the top of the file
Oh, to opt out?
that says,
No.
don't do this?
Because the first thing happens is before I even look in the file, is I just opted in, and so it's there as you roll forward. This was my thinking. Your
It's
suggestion
because
is
you weren't even going to read main until.
no, I wasn't even going to read the first line. You know, if you look at like shells things, the first line says pound bash or pound Z shell or pound blah blah blah, and then the shell interpreter standardly starts and looking at an executable file, looks at the first few characters, and he sees those, he starts the correct shell to interpret. And if not, he may be down some other path for how you execute the thing. So maybe we could go there. Certainly, Emacs looks at the first line. If he sees a pound something with a language in it, he immediately switches to this kind of a language mode for how he edits and displays and shit. Like he's aware of files this way. Yeah, could go there. And so you put a pound in simple and followed by no standard lib. And then okay. So then I have to parse at least the first line, looking for a slash slash, probably slash slash to end of line comment that says no standard lib. Yeah, STD. This must be Aaron. You know, typically when you write messages, your spelling is atrocious. I thought mine was bad. Yours, it's way worse.
I had noticed that, yes. Funny, all my teachers through grade school noticed that too.
Fortunately, that becomes less important the older you get.
Yeah. I've definitely found that whenever I fill out the anonymous feedback thing on manager reviews, that the manager comes and talks to me afterward about how terrible my spelling is.
Yes. Yes. Oh, I did a couple manager review cycles where I was the manager reviewing. And probably 3/4 of the reviews, I could tell who the person was based on their comments and feedback and stuff. It's just so obvious. This is anonymous. Except I know
Anonymous
who the
user
hell you
thinks we should
are.
do Aaron's pet project.
Yes. What's Aaron's pet project? Oh, I'm sorry. This is just you. Yes, I don't have your face up. Ah, fine.
I mean, the pet project I pushed most when I was at Twitter was Blue Sky, but then they're like, go do that outside the company, which fine.
And are you at Blue Sky now? You said it told me once. I think you said something.
I am no longer at Blue Sky.
Okay. Well, I have a Blue Sky account now, so help make you proud. I'm waiting for Twitter to implode, but it's too much momentum to implode right away. The implosion is slow. All right. I am running downhill. So new topic, and then I'm going to look for a chance to bail here.
I guess my last question is AA still moving, or basically simple is where the momentum is?
I had to stop and pick up a consulting gig to pay my bills. So, and then I got a lot of traction on Simple. So I have AA pending. There are a bunch of really cool things in it that I've sorted out completely. And I need to go through and finish it.
Yeah, I was
Part of
wondering
the,
if working on simple was going to make you go back and change a lot of stuff in AA that you thought made it more
the
community friendly to commit to.
right, the presentation of how the code looks and some of the breakdowns of structures and things definitely turned out better in Simple. So there is a call in my head to redo some of the base things in AA. It'll be a lot of work, and I want to sort of lock down some of the other things I figured out. I figured out how to really fold Henley Milner and full-fledged forward flow typing like you get out of C or Simple or Java in a meaningful way. Like I can totally blend them in the type system. I figured out a thing I want to call a virtual field, which is like a virtual function, but it's on a field. And I can infer which field you mean by context. So you don't have to name a specific field. I'll know which one you mean. That turns into a lot of other things, like I know how to totally handle various kinds of complicated overloads. There's a lot of cool things that come out of that. The sorting of what it means to add ints and or floats and or whatever in a language that has Hindley Milner, like Haskell went to type something. What was it? There was a damn thing they called it. It's basically type classes. I think I have a much better answer in my overload strategies. Um, it does a lot of other things that are very interesting as well because the virtual call, and then it can be super cheap. The lookup on the virtual call, a normal load of a field would take a base and a constant offset based on where the field layout landed. So in our little examples given here, the struct x has an x.f. Well, that's a load of the base of x plus an offset to the f field. Okay. In the virtual field case, that offset is dynamic. It's a load instruction in hardware with a base and a second register instead of a constant. And that's the only difference in the cost for the implementation of virtual fields. But it lets you write things like here I might say, da, 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 I'm not going to name the field. I'm not going to name the field. And I'll either be ambiguous if I can't tell them apart, but if I can tell them apart with the typing system, I'll tell them apart in the typing system. One of these returns a float for whatever reason. One of these returns a string for whatever reason. Up here, this guy returns me 17, no, float. So he returns me 3.14. And this guy's returning me, a string. And I can go sort that out and say, oh, you must emit load x.f, and you must emit x.f here, and you must emit load x.h here. And you don't have to name the field. So it's kind of a funny thing. And then because of
Could
that,
x of 3 alias to that?
Not yet, because I know, because I assume that you intend for that to be a function call, and therefore x has to be a function type. It's not. It's a struct. So you have to have a dot and an underscore. The one place where I play some loose games with syntax is if you're using an operator, then he'll default to the left-hand side is some kind of a struct whose field is the operator name, and which function of which operator you pull, like int plus int, int plus float, float plus int, float plus float. I'll do the correct conversions by picking the correct function. And ints and floats are structs or have a class. The class for int and the class for float would be what you get. So there's a bunch of shit that's been worked out that work for play exactly the shortcuts you're trying to think of for operators. So you get a clean operator syntax that looks perfectly normal. It just does this funny thing under the hood. But no, in this case, you have to say, what are my examples for like AA here? It's just like funny things. It's been a while. Let's see here. I want to be passed in a name string and a hex value, and I'm going to return you a color, which is just going to be, whoops, hey, go away, Intel. I'm a hex. Let's see here. I'm going to say a name. Whoops. Axis. I'm just wrapping some arguments here to make a color struct. And then we say red is equal to, well, the name red is, red. The hex value is 1, 2, 3, and maybe, I don't know. And blue is, well, blue. And, 4, 5, 6. And then I have a lighter, moving to a little nicer, which takes a color, C, and says, oh, I want to make a color where I want to take the C name and add the word light in front of it. I'm doing this what's way more ceremony than I need to because it's been a while since I looked at it. And then I need to add one to the other side. And then I get a color object back. Actually, don't need this either. And then I can say, lighter red, and that's going to be, light red. And it looks like 2 through 4. Right, and then lighter blue. That's the obvious thing. Finish this out really quick here. 5, 6, 7. Okay, so what happens in here is whatever comes in, I'm going to figure out that you mean the string field or the number field, and that build from there. I think actually, I think I'm probably happier to do this. I had some other guy that made it more clear how crazily much inference is possible here. Just nuke that. That's what I should have done all along. Oh God, every time you do an @ it confuses the hell out of the thing. Okay. Okay. So something like this, and I'm doing all kinds of inference on the types of things, and I can say light red and light blue, and then I can come down here and say, oh, I have what's a good way to do this here? I want to print a normal print function, which is usually a string. I want to print the light red or whatever. And he'll say, well, oops, you want the string version, so you get the string red, whatever. So there's an inferencing thing that can happen here. It can be nested quite deep. And I can track it through any number of recursive function calls as deep as you like. And the implementation will be you'll pass along an offset in a register and apply it to the load at the time that you're pulling the field out or the store. The offset will show up. And that's all bakeable down at compile time. I don't have a good example ready. Sorry. But there's definitely an inferencing game here that's pretty straightforward. That was my point about, oh, you remember from some months ago about like factorial with floats in AA can totally do that. That's what the operator syntax thing is using, this overload notion. Fact is a function that takes an n and says if n is less than or equal to 1, return n, otherwise return 1, otherwise return n times, fact of n minus 1, and then fact of pi, right? Okay. So what is the type of fact? Well, the type of fact is the function which allows you to compare against 1 and multiply against itself, the recursive type of fact, the n, and subtract from 1. That would include floats, ints, matrices, any number of other fancy types that happen to complex numbers, any fancy types that have an add or subtract. So subtract so it can compare against 0, and a multiply. And that includes a lot of things. And that's what the type that AA infers here. So
if I have one int and one double, I'm going to get 2 copies of fact when I'm done compiling?
The first go round will get you the one copy that does generic things. Then it's up to the optimizer to see that sometimes fact is called with this flavor and sometimes that flavor, and he will inline and then type specialize. But the first cut is I take a generic version. The generic version will know the type of the thing that is being passed in and carried along with the value, like a 3, also come with the int class. So when he says, how do I multiply? He'll take the thing I got, the 3, and I'll look up multiply in the int class. And I'll say, oh, this is how it's done. And if I take a matrix, I'll have a matrix and a matrix class. So the class gets passed in.
And as long as it's not megamorphic, some optimizer should eventually
Yeah.
collapse it to the switch statement.
Right. Right. If you don't, yeah, if nothing stupid happens, he can totally clean it up and get you into exactly the top level switch. Hey, what's the class? And then I'm sorry, yes, type level test is the class is this or that. Then at the implementation version, the class goes dead, and you have the obvious. Hey, it's n equals n times 1 or whatever it's going to be. You get the obvious, quick, fast math version.
If I have two call sites and one call site is always an integer, and the other call site is megamorphic and can be 30 different types,
It's up to the optimizer.
will it just go megamorphic and every single place where it's called it'll be megamorphic, or will it figure out that, oh, at this call site it's actually single form and at that call site it's megamorphic?
That's up to the optimizer. C2 totally handles that case explicitly. Each call site is looked at independently. If I have a call site where the type is known statically, it turns into a static call. As a static call, it might get inline. As soon as it's inline, it's just constant folded up however you go. If it's megamorphic on another call site, he'll do things to help with megamorphic. But if he really believes it's megamorphic because profiling says megamorphic, yeah, you get the expensive megamorphic thing. I mean, that's right now in Java everywhere. All right. I am really wiped out. It's been a long, tiring flu. So let's see. Yep. Okay, is another goodbye. So nice talking. And hope by next CCC I am all better.
Cameron, are you coming to us from the cloud?
I guess
Still
so.
better snark than mine.
He uploaded himself to the
He's been
cloud.
uploaded to the cloud. No snarky comment? Oh my
Oh,
goodness.
I said I guess so.
Oh, the sound wasn't on yet.
No snarkiness today.
Okay. All right. Well, it was nice seeing you.
Good to see
Bye-bye.
you.
Bye.